Alright, so welcome back to part 2 of the series of lecture on thermal properties. Prior to this, I talked to you what is melting and freezing and what the process is like, and you should remember that any change of state always takes place without, now this is important, without a change in temperature. Okay, remember this, important stuff. Okay, so now let's talk about boiling. So what is boiling? It's the change of state from a liquid to a gas at a, think about it, fixed temperature, because there is no change in temperature when there is a change in state. So for a pure substance, this process takes place at a definite temperature. Okay, it's called the boiling point. So it's called the boiling point. And condensation is the opposite. It is the opposite of boiling. So whereas boiling changes state from liquid to gas, condensation is from gas to liquid. It's just the opposite, right? And likewise, compared to melting, freezing, the presence of impurities, and pressure will affect the boiling point. Okay, so the boiling point is lowered if the pressure is reduced, but will increase if the pressure is increased. And the boiling point of water is raised with the presence of impurities. Now, a lot of people always ask me, sir, what will happen if you are exposed to space, right? So in space you are in a vacuum. You are in a vacuum, and in a vacuum there is no pressure at all. There's no pressure at all. So if there is no pressure, what will happen to the boiling point of your blood, which is essentially a liquid, right? Go watch this video. I provided the link here. Go and check it out. It's quite interesting, and it will answer one part of your question: what will happen if you're exposed to space? All right. So right now, what I'm going to do is I'm going to teach you how to draw the heating curve and the cooling curve of a substance. So let's draw the heating curve first. So I'm going to plot. Let me get the ruler out. Hopefully this works with my Wacom touchpad. Hopefully it'll work. Let's give it a try. Oops. Okay, so I'm going to draw a axis. Draw an axis, and okay, this is not the best of going to be the best of drawings. Okay, so pardon the failed art. So on the y-axis, what I'm going to do is I'm going to plot the temperature measured in, let's say, degrees Celsius, and on the x-axis I'm going to plot the time, maybe measured in minutes, okay, because boiling, freezing and whatnot takes usually a bit of time, depending on, of course, how much energy is provided. So let's say I start off with a solid. Let's say I start off with a solid at a certain temperature. And what happens is that I'm going to give this solid heat. And as we all know, the temperature of the solid will increase. So it's still a solid. However, at a certain point, and this certain point is called the melting point, the solid will start to melt. Alright? And as I keep telling you, when there is a change in a state of matter, the temperature does not change. The change of state always takes place at a fixed temperature. Therefore, the temperature remains constant. During this period of time, I will have both solid and liquid state because the solid takes time to melt, right? However, when all the solid has melted, I will be left with liquid. And assuming I keep on giving heat energy to this substance, right, the temperature of the liquid will keep increasing as well. But then there will come a point in time whereby the temperature of the liquid reaches something what we call a boiling point. Now remember, every substance will have its own melting point and boiling point. I'm keeping this general. I have not mentioned a specific substance. Alright? So when this substance, which is in a liquid state now, reaches its boiling point, it will start to boil. And again, during boiling, the temperature will stay constant. And during this phase, I will have both liquid and gaseous states. Once all the liquid has boiled off, and assuming I give the gas more heat, the temperature of the gas will start to increase again. Okay, so this is your typical heating curve. So here I'm left with gas, and this is all in gaseous state. So you got to learn how to draw this and interpret this heating curve. Remember that. Okay, now I'm going to teach you the opposite, the cooling curve. So let's come to the next page. Now what I've done is that I've created a bit of space for my lecture series. Your notes that I've given you will have space to draw these two heating and cooling curve. Alright, so let's draw right now the axis. Again, pardon my drawing. Oh, that's not too bad if I do say so myself. Same thing. On the y-axis, I'm going to measure the temperature, measure in degrees Celsius, and on the x-axis, I'm going to measure the time measured in minutes. Alright, so the opposite of a heating curve is a cooling curve. So this is your cooling curve. Right, and in the cooling curve, we will start in a state of gas. So I'm going to have some gas here, and I'm going to cool the gas, and the gas is going to cool down and cool down and cool down until it reaches a certain temperature. Yes, based on the bell, you will know that I'm recording this in school. Okay, so based on the temperature, when it has hit a certain temperature called the condensation point, or I can even call this the boiling point, it starts to condense from a gas into a liquid. And during this change of state, by now you should already be very familiar, the temperature stays constant. So from a gas, it's going to condense into a liquid, and during the condensation phase, I will have gas and liquid states. So assuming I'm going to take out more heat, I'm going to remove more heat, I'm going to cool down this substance, the liquid will start to decrease in temperature. Okay, now over here I have liquid state. Right? And at a certain temperature, special to this substance, is going to reach a freezing point. The point where it freezes. Or I can even call this the melting point. It's the same temperature, remember? And during the change in state, the temperature stays constant. Right? and over here I will have both liquid and solid states. So after all the liquid has frozen into a solid, the solid, assuming I'm still removing heat from it, the solid will start to decrease in temperature. So now I'm left with a solid. Okay, and it will drop and drop and drop and drop until it reaches thermal equilibrium, or you just stop removing the temperature from it. Alright, sounds good? So this is the cooling curve, which you also must know how to interpret and draw. Okay, so what is latent heat? I've been talking about latent heat when I remove, especially here, during the process of change of state of condensation and freezing or solidification. I am removing latent heat. Latent heat. This is a key word. So since it is a key word, I am going to highlight it. I'm going to highlight this, latent heat. But during the other normal processes, when I'm removing heat from already a solid and there's no change of state, I can just simply say that heat is removed. So get the difference? Latent heat remove only during the change in state, and heat remove only during a non-change in state. So what is latent heat? Latent heat is the heat required to change state without any change in temperature. Okay, so remember this. To kind of complete the picture, let me also do this. Right now, let me change the color. Alright, because I'm adding heat. So over here, when I add in heat energy, it is a change in state. So therefore, I'm actually adding in latent heat. And this is also latent heat. Okay, but let's say during a normal process where I'm just adding heat to, let's say, a liquid, or you can just simply say that it is heat that is being added in. Okay, so I hope you are clear about the cooling curve and heating curve, and also what is boiling. And same thing, if there's any questions, please email me here, yo_haig_jean@sass.sg. Okay, so this is the end of part 2. I will start part 3 shortly. See you in a bit.